Lesson 16.
And I'm going to ruin the quiet for you. Okay. Lesson 16 is a big old log review, which logs lead us to exponential equations. So logarithms of products and quotients, logarithms of powers, and exponential equations. First thing up here is some basic reminder rules. So the log of a product. So log of mn is equal to the sum of the logs. So you can take multiplication within a log and break it up into those two logs being added. Same thing works for division. Division within a log. So we're not saying two logs divided, but division within a log can be broken up into two logs being subtracted. And then if you have two logs that are equal to each other and their bases are the same, then that means the insides are the same. And so you could drop the log base b part and just have x equals y and solve that equation. Okay. So let's jump into example 1 here. Log base 4 of x plus 2 plus log base 4 of 5 equals 2. And we are solving for x. You got me a starting point?
We can multiply x plus 2 by 5.
Okay. Two logs, same base, can be written as one log, or two logs are being added with the same base, can be rewritten as one log where the insides are multiplied. So log base 4 of, what is x plus 2 when I multiply it by 5? 5x plus 10. And it equals 2. Now what?
Yeah.
Left, right, middle? Because once it's in log form, you can take it out of log form by applying left, right, middle. So left, right, middle is going to say 4 to the second equals 5x plus 10. 4 squared is 16. So I have 5x plus 10 equals 16. Subtract the 10. 5x equals 6. X is 6/5. Questions there? Okay, example 2. Natural log of x minus 1 minus natural log of x plus 2 equals natural log of 14. Okay, two logs being subtracted can be rewritten as one log where the insides are being divided. So natural log of x minus 1 over x plus 2 equals natural log of 14.
Drop the natural log.
Okay, they're both natural logs, which by default means equal bases. So we can drop off the logs and just have x minus 1 over x plus 2 equals 14.
Multiply by x plus 2.
Okay, I have a fraction. I don't want a fraction, so to get rid of a fraction, get this so we don't have fractions, multiply by the denominator. So I'm going to multiply by x plus 2. What I do on one side, of course, we're going to do on the other side. The whole point of multiplying by x plus 2 on the left is that the x plus 2's will cancel. X minus 1 equals, what's 14 times x plus 2? 14x plus 28. And
13x equals Negative 29.
Okay. So if we subtract the x over to join the 14x, we have 13x on the right. If I subtract the 28 to the negative 1, I have negative 29. And so x is what? No, check your math. It's negative 29, not negative 39. Yeah. Fraction thing. Negative 29/13. If I divide both sides by 13. Well, I heard the 3 and I was like, did I hear that right? Why is he saying 3? And I was like, oh, 29, 39, you know.
Same number.
Same idea. Okay. Your log rules are coming back to you, right? Example 3. Oh, before we go into example 3, this is just to review that if you have a power, such as log base b of m to the c power, that power can be moved and written out front as a coefficient. So c times log base b of m. Okay. Thoughts on example 3 then?
Do you put the first one with log base of 8 to x to the second?
Yeah. You need to move that 2 up into the power first, because the next step is going to be to take those 2 logs that are being added and combine them into 1 log. But you can't combine 2 logs into 1 log if there's coefficients out front. You have to take care of the coefficient first. So move the 2 up into the power. So log base 8 of x squared plus log base 8 of 4 equals 1. Now I have 2 logs, same base, being added. So I'll rewrite it as log base 8 of 4x squared equals 1. Next step is left, right, middle. 8 to the first is 4x squared. Good news is 8 to the first, it's just 8. So if I have 4x squared equals 8, then divide by 4, x squared equals 2. If x squared equals 2, I take the square root of both sides, plus or minus the square root of 2. Done? Why might I suggest that we need to check our answer here?
Because one of them could not work.
What could possibly be a problem? The plus or minus? If you go back to the original equation, we have to be able to plug this into the log. Can we take the log of a negative number? And here is, I don't know if you guys, I feel like we did this the other day. Didn't we do log graphs? Say the other day, like it was just recently. Maybe it wasn't, but we did them, right? A log graph, a logarithm graph looks like this. So what x values can go into a basic logarithm graph? Positive ones. And so the only answer that actually works here is square root of x. Does that make sense? So just kind of be aware, especially in that square root type situation, when you're taking the square root of something and you're creating two answers, double check yourself.
Shouldn't it be 2 instead of square root of x?
Definitely. X is equal to the square root of x. I just wrote a very false statement. Very false statement. If I looked back at these later, I would really wonder what I was doing. Yikes. Okay, better. Thank you. Oof. Everyone else caught that and just looking at me like I'm crazy there? Or?
Well, I wrote that down and I was like, wait, is this supposed to be 2?
Yeah, definitely. Okay. Example 4. Have you guys started it? I know some of you have. What are you doing first? Okay. Now, thoughts here. So the fact that they all have negatives, you can give them all exponents that involve negatives. Could we multiply the whole equation by a negative to make them all positives before we begin? And then it won't get quite so ugly along the way, maybe? That would be my recommendation, is that you start by multiplying every term by -1. So -2 natural log of 3 becomes +2 natural log of 3. Minus natural log of x minus 1 becomes plus natural log of x minus 1 equals positive natural log of 1/4. Notice multiplying by that negative does not change the insides of any of my logs. It just changes the coefficient. And so now, deal with the power. Take that 2 and put it in the power there. So natural log of 3 squared plus natural log of x minus 1 equals natural log of 1/4. What's next?
You can multiply the first 2.
Okay. 2 logs being added can be rewritten as 1 log where the insides are multiplied. So it becomes natural log of, what's 3 squared times x minus 1? 9x minus 9 equals natural log of 1/4. And
Drop the natural logs.
it's both natural logs. So drop the natural logs and you just have the insides. 9x minus 9 equals 1/4.
Add 9.
Add 9. So 1/4 plus 9.
37/4.
Yeah, my brain first goes to 9 1/4, but then it quickly converts to 37/4. If it's 9x, what's the easiest way to solve for x? Divide by 9 or multiply by 1/9. And I'm going to multiply by 1/9 route as I write out just because there's a fraction on the other side. So 9x equals I even said it wrong there, didn't I? I caught this one before Trevor could get me though. Okay, x equals 37/36. Mallory had definitely already noticed because she said it as soon as I said it. Okay, questions there?
Nope.
Okay. Those were more log equations. On the back side, we're going to talk about exponential equations. Couple of comments there. One, match the bases if you can. So if both powers, or both powers of the same number, and then also taking the log of both sides to pull down the power. Those are going to be two of our techniques that we're going to go back and review.
We'll have to review Monday.
Mm-hmm. Remind me, and I can hand out the review worksheet today if you want it. I have it copied, but I forgot to set it out, so I'm going to forget. Okay. Solve 8 to the 3x plus 2 equals 16. It says solve it for x without using logs. Thoughts? Thoughts that are true about 8 and 16? Are both powers of 2? What do we know about 8? 2 to the third. So I'm going to write this as 2 to the third raised to the 3x plus 2. And what do we know about 16?
2 to the fourth.
2 to the fourth. Surprise, surprise. They can be rewritten with like bases.
Oh, wow.
I know, shocker, huh? If the bases are the same,
Drop them.
you can drop the bases and just set the exponents equal to each other. So now I have 9x plus 6 equals what? 4. Okay. 9x plus 6, we're going to subtract 6. So 9x equals negative 2. Divide, and x is negative 2/9. Okay. Example 6.
Factors of 2.
8 can be rewritten as 2 to the third, but what about 10?
Nope.
No.
It's 2 times 5. You can't write it as a power of anything. So what was plan B if we can't make the bases the same? Yeah. Remember taking the log of each side? And that's just writing log out in front. Officially, you can use either log. LOG log, common log, or LN log. In this case, it's going to be in your better interest to use LOG since there's a 10 involved. So the log of 10 to the negative 2x plus 2 equals log of 8. Next.
We can move the exponent out front.
Okay, take that whole exponent of negative 2x plus 2, move it out front. It's now a coefficient of log of 10. So negative 2x plus 2, I put it in parentheses, times log of 10 equals log of 8. Do you remember anything about log of 10?
That is a base.
And logs that have the same base and the same insides, they're really just equal to whatever power is up here, which the invisible power here is 1. So log of 10 is just equal to 1. So now my left side all of a sudden becomes negative 2x plus 2 equals log of 8. And life just got better. I mean, it's still not a pretty problem, but I mean, that definitely improves. Solve for x, yes?
Yeah.
Subtract 2. I'm going to write it as negative 2 plus log of 8. You can also write it as log of 8 minus 2. Just be careful. That minus 2 is not part of the log, correct? So that would be the only advantage of writing it out front is there's no way it can magically become part of the log. Divide by the -2. So I have -2 plus log of 8 divided by -2. And calculator does the work.
That's what I got.
AP Saxon book, I have it written with 4 decimals in my notes. So 3 to 4 decimal places would be good here. 0.548 and then 5, because the 5 tells that 4 to go up if you have 4 decimal places. Otherwise, it's 0.548. Okay. Problem 7. What's the better plan here?
Natural log.
Take the natural log. Because it's base e, take the natural log of both sides. So natural log of e to the -2x plus 3 equals the natural log of 5. Natural log of e is base e. So natural log base e of e to the -2x plus 3 is just going to equal what?
-2x.
It's going to equal that exponent. So -2x plus 3 equals natural log of 5. To solve for x, we're going to subtract 3 and divide by -2. So -3 plus natural log of 5. And then -3 plus natural log of 5, all divided by -2. Beware, if you put natural log of 5 minus 3 on your calculator, you realize you need to make sure and close the parentheses there, yes?
Yeah. Yep, that's what I got.
0.6953 if I round.
Yep.
Okay. Last one. What is our step 1?
Make it a log.
What's the first step you took without me? Can you get 5 and 6 to be the same base? No, so we're going to need to take the log. You want to do common log or natural log? It technically doesn't matter. No, we've got bases of 5 and 6. Nothing's being nice like it has been the last 2 problems. So log of 5 to the 2x minus 1 equals log of 6 to the x minus 2. Next step is to, pull the exponents out front. Notice I'm going to put them in parentheses. 2x minus 1 times log of 5 equals x minus 2 times log of 6. Okay? Thoughts on what to do next?
Yeah.
I knew it. As soon as I closed that door, I thought, of course. Right, almost. You did.
Of course, only me.
No, not only you. You're just the last one to come back. Okay, what are we doing, guys? This is 2x minus 1 times log 5. This is x minus 2 times log 6.
Logs on one side.
Okay. But I'm not sure that's going to be easily doable right now. Because if we want, at this exact moment, to get logs on one side, x's on the other side, we'd turn into division and it wouldn't work out pretty. Log 5 and log 6 are basically numbers, right? These are numbers that are outside a set of parentheses that has two terms in them.
Let's distribute.
That's where I was trying to lead you. You followed well.
I feel like if it was on the other side, like the logs on the other side, I would have seen it way better.
I get it. And this is where that important point of you can distribute from either side is a valid, important thing to realize because it's not always going to be written like that.
Yeah.
Okay. When I distribute, so like 2x times log 5, I'm going to say 2x log 5. If I say log 5 times 2x, is that 2x in the log or not in the log? So, minus 1 times log 5, so just log 5, equals x log 6 minus 2 log 6. You guys should have known. Things were going too easy. We have to get a little bit more difficult one in here. Now what? Okay.
Now we can do that.
Now I'm ready to, let's get any x terms to one side, non-x terms to the other side. Which that means I'm going to keep 2x log 5 on the left, and I want to move over x log 6. That means my minus log 5 needs to go to the other side. So now I'm going to have 2x log 5 is staying where it's at. I'm going to subtract over x log 6 equals, we're going to add over log 5, so log 5, and then we have the minus 2 log 6. And I could have written that second side in the other order. I'm not sure why I didn't, other than I put the positive first. So do I have my x's on the same side?
Yep.
What's that next step?
They combine the logs into a division thing.
I really like seeing things,
I don't know the word for anything.
fraction thing, division thing, exponent thing.
Yeah.
If we do that on the left, though,
The thing.
my x's would have to go in the powers, and that's going to get ugly real quick. Unless I was looking for GCF, factor out GCF of x. I guess I can't 100% say that method wouldn't work, but I'd have to work through it to know. Yeah, and that's I feel like we get to a stuck point. But yeah, so GCF of x on the left. If I factor out x out front, I'm left with 2 log 5 minus log 6. Still equal to log 5 minus 2 log 6. And how do I get x by itself? Divide. It's x times that parentheses, so we're going to divide by the parentheses. So x is going to be equal to log 5 minus 2 log 6 divided by 2 log 5 minus log 6. And I guess technically 2 logs being subtracted, you could put them into division, but at this point, you're already going for a calculator here.
Yep.
I mean, there's no...
I think we've done too much graphing because I keep wanting to hit the graph instead of the answer.
That's what I got.
Negative 1.382, the 6 tells the 2 to go up, so negative 1.3833.
Beautiful.
I don't know if that's the word I would use, but
It's beautiful that we're done.
That last log problem was a little bit more lengthy than some of the others, but it was doable. I mean, that's all skills you've seen.